So hello guys, welcome back to my channel. So today's video would be about Introductory Econometrics, where I would be discussing 6 questions with their comprehensive solutions, and we would try to cover the whole course in those questions itself. So let's begin. So this question is from simple linear regression analysis, where the parts are as follows. First of all, you will have to interpret the slope coefficient, construct a 95% confidence interval, interpret R square, testing for overall significance of the model. So let's move to the solution now. So the interpretation is as follows, like if price goes up by rupees 1000, then mean predicted sales would reduce by 2.375 units. The confidence interval in second part can be calculated by using the simple formula that would be the beta 2 hat plus minus standard error into the t ratio value. The R square interpretation would be that 64.58% variation is sales is explained by price. Now hypothesis testing we have done using the usual formulas, you can check out in the solution. Moving to the next question, this is also from simple linear regression unit, where it says to find out the estimated forecast for the monthly sales revenue ESS we have to find out, and we have to prove that F equals T square in simple linear regression analysis. So let's move to the solution now. Here you can see that we have done the mean forecasting using confidence interval and also found out the variance using the formula as written here. Now for ESS we can see that the formula would be beta 2 hat square summation xi square, and we have computed it as follows. Now for proving F equals T square, we have written the usual F stats formula, which would be R square upon K minus 1 whole upon 1 minus R square upon N minus K. Now we have solved it and proved it to be ESS upon sigma hat square. Now on the second side we have T square in slope coefficient, where we have taken T square for slope coefficient, and there also we have proved it to be sigma ESS upon sigma hat square. Now moving to the next question, which is from multiple linear regression analysis. Now here the question gives some data for yi, x2i and x3i, and asks us to find out the estimated parameters and also the question in the black box. So let's begin. So in this question here we have computed everything neatly using the long formulas in multiple linear regression analysis. You can see that. Also the PDF for the notes can be found out in the description of this video, so do check it out. Here we have computed sigma hat square equals ESS upon n minus k, which would be summation ei square upon n minus k. Now here, after applying those formulas, we have finally found out the variances and standard errors of estimated parameters beta 1 hat, beta 2 hat and beta 3 hat. On right hand side we have checked for the overall significance. The model is significant using normal hypothesis testing procedures. Now the next part also says to check individual significance for coefficient of x2i, which is beta 2. So we have used the hypothesis testing measure and we have concluded that beta 2 is statistically insignificant. Now here you can also apply right tail test giving some economic theory. I have taken it to be left tail test. Using the formula for adjusted R square, we have also done that. Now moving to the ANOVA table, that would be we have to include TSS, RS and ESS. The formulas are here also written, and dividing by the degree of freedom, we can have the last column which would says mean sum of squares, and the answer is as follows. So time for question 4. This question is specifically from the unit functional forms, and we have taken a polynomial regression model where it says to interpret the sign of two slope coefficients and at what level of output the AC will be minimum. We have to also compute the adjusted R square, and hypothesis testing is also included. For first part we can see that when output goes from 0 to 1, the mean predicted cost decreased by 0.175 units, but at an increasing rate of 2 into beta 3 hat units. So here we have calculated the AC by dividing yt hat by xt, and then applied normal derivatives procedure and arrived at the minimum for AC. Now to prove that R bar square is always less than equal to r square, we have used the following procedure. Now testing for the sigma square, here we have applied the test statistics which follows chi-square distribution and also used a confidence interval approach. You can see the formulas here. So this question is from double log model or log model, which says to interpret the own price elasticity and cross price elasticity, and also to check the hypothesis that own price elasticity is unitary elastic or 1 at 10% alpha. And we have also got to draw the ANOVA table. So here we have done the hypothesis testing and also made the ANOVA table using the formulas. The last question is from the chapter of dummy variables. Here we have to first interpret the coefficients of DI and DI into stock market performance variable, and also to test the hypothesis that the compensations relation with stock market performance remains the same irrespective of takeovers by the firm. So here we have first interpreted, and here we have checked for the statistical significance of interaction dummy variable. Now there are still 3 chapters left which would be on multicollinearity, heteroscedasticity, autocorrelation, and one more that would be model specification error. So here I have listed out the types of question that can be asked, basically based on detection test, consequences, and remedies. In heteroscedasticity we have Park test, Ledger test, White test, and Goldfeld quant test. For autocorrelation we would be having Durbin-Watson D test, Durbin-Watson H test, and Bruce-Godfrey test. For the remedies, there would be the cases where sigma square is known, unknown, or rho is not known or unknown. So for my handwritten notes on Econometrics syllabus, you can check out the PDF link in description, which would be added 1 hour after this video premieres. Thank you guys for watching, and if you love the video, love the content, do like the video and subscribe to my channel for more such content.